So today we are going to begin arithmetic with numbers. Now, how do we do arithmetic on numbers? So arithmetic on numbers will be some operation on groups of objects. Because how do we represent groups of objects? In other words, how do we represent collections of objects? Let's say I bring cups from a shop, and let's say 3 of them are glass cups. So let's say I have 3 cups of glass, and let me use different color, and 2 cups of plastic. And now in the physical world, let's say I pack those cups together into one packet. So a natural question will be, now how many cups do I have? In total. This is the physical thing going on. So we know how to assign a multitude or numerosity or count of objects to this group, which you would agree with me is 3. We have 3 cups of that type, and to this group 2, and to this group you would agree with me that we have 5 cups when I don't want to distinguish between plastic and glass. But how do I, because we need, in this conceptual and mathematical world, we need to represent these physical objects and groups into some mathematical objects. The problem is, when I say 3 glass cups, I do not want to distinguish between those glasses. Between those cups, because they are just cups of the same type, and these are cups of the other type. And here I don't even want to distinguish between the materials, so I just say, okay, they are just cups for me. So if I want to represent this, because they are indistinguishable, and because I care about repetition, if a cup is 3 times, I want to know that 3 times. So then I need a mathematical object where let's write G for this, so glass, glass, glass. So G, G, G. And let me use this square bracket so that you do not confuse it with sets. With sets you use a different kind of bracket. And I'll map this, so to plastic cups. Here I have, you see, glass cups. So this will be mapped to plastic, plastic. Now these are not sets, because in sets we don't repeat things. Now, just as a side note, when will the concept of set be useful here? Let's say I am not interested in the count. I just want to know that, okay, I brought these cups and I just want to classify. So this whole packet contains plastic cups, I don't care how many are they, and glass cups. So if I just want to have an abstract collection of types, then I will have set. So I have cups of type G, glass, and cups of type P, plastic. Yeah? And when I write G one time, because I'm only interested in the type, so I don't have to write G 3 times, yeah, because I'm not interested in the count. Mathematically, this object is called a set, you know that. Yeah. So no repetition, and the order doesn't matter. It doesn't matter whether you write P before G or G before P. This is a different type of collection. Yeah. This is usually called multi-set. Some people also call it bag. So this is one multi-set, a multi-set of glass cups and a multi-set of plastic cups. Now just imagine every textbook in the primary school level, they don't distinguish between, they will always bring these examples of sets, tea set, yeah, a set of cups. They are all indistinguishable, and then they will use set. I mean, if you want to use, let's say you don't want to use multi-set or this new object, and you want to do everything with sets, then you need to do some artificial labeling. So you cannot write G and P then. Then you will call this G1, G2, G3. So let's say I want to represent this by a collection of objects where I take into account the count or the multitude or the numerosity. Then I'll have to label this as G1, G2, G3, yeah? And P1, P2. Now, if you are happy with that, you can do that. You can do whatever you want. But I don't think this is useful. Yeah, I mean, the best mathematical object to deal with these situations is the idea of multi-set. So we will use multi-sets as mathematical objects representing collections of objects in the physical world, because we do care about their counts even if we don't want to distinguish between them. So now let's remove this now and recap what we have done so far. I have 3 physical glass cups here. I represent them by a multi-set there, yeah, just convenient labels G, G, G. I have 2 plastic cups, another group, another collection. Here the mathematical object needed to represent that is actually this multi-set. Now I need to pack this in the real world. In the mathematical world, I will combine these 2 mathematical objects. That combination will give me addition. Yeah. So if I combine, let's say if I take these 2 and I combine them, yeah, or I can also say join. I join these 2 multi-sets. Now I have a new multi-set. A multi-set which has all the G's and all the P's. Yeah. I know the size of this multi-set is 3. The size of this multi-set is 2. The size of this combined multi-set is, we just count it. 1, 2, 3, 4, 5. Yeah. So that gives me 2 examples of addition. So what I have established is that I can give meaning to 3 cups plus 2 cups, and this gives me 5 cups. Yeah. I don't care about the material. And now this is an instance for cups. I can apply this to any collection, even to abstract collections. Remember, in the last lecture, we were dealing with abstract collections. So numbers have their own existence independent of the physical objects, which mean that if I repeat all this exercise, if I don't care about the real world, I start with abstract multisets. Abstract multiset, an abstract multiset of 3 members, an abstract multiset of 2 members or 2 objects. And if I combine them, then I will simply have 3 plus 2 equals 5, because now I don't need the physical word. 3 plus 2 plus 5. Now try to recall those two interpretations. A number represented the size of a collection. Remember, at that time I was using the word set because I knew you only were in a position to understand set. Now we know that we are using multi-set basically. So when I say group of objects, I'll be referring to a multi-set. So if I want to read this equation, 3 plus 2 means 3 is the size of a multi-set with abstract objects. I don't know even, and I can construct that multi-set from empty sets as well. Another set with size 2, which means 2 elements. No, not sorry set, multi-set. And now if I combine those two multi-sets and make a larger multi-set, this larger multi-set will have 5 objects or 5 elements. So I have given meaning to addition, represented by the plus sign, both with denominations, cups, glasses, pens, flowers, and without denominations. So addition is defined equally for pure numbers as well as for quantities. So when a number is used to represent a quantity, you can add one quantity with another quantity, provided you use the same denomination. You will get a new quantity with the same denomination, and the count or the size of that quantity, the pure number, will be just the number of these two. So this addition is helping you do that addition. It's actually this 3 plus this 2 is this 5 cups. By the way, before I get to that, this was just one interpretation where the number represented the size of a group. Remember, I gave you another interpretation, and that was the labeling or indexing. You can do that here. So here, if you think of labeling here, 1, 2, 3. Labeling here, 1, 2. But when you combine these two multisets into a single set, you can start the labeling here, 1, 2, 3, 4, 5. You see? So the labeling, what do you mean by addition in that labeling interpretation? You just continue the labeling. You started labeling for one multiset, and then you continued from that point onward. So instead of starting from 1, you started from that next number. So whether you interpret a number as a size or as a label, plus or addition has a very clear meaning. And you have to keep in mind join, combine, and things like that. One more thing, the way I explained this example gave the impression that I start with one multiset and somehow another multiset comes here to join it. This is called dynamic joining. This is very easy to comprehend, but you do not have to limit yourself to this, because I can start with this. Maybe somebody has done this combination for me, and I just look at this packet and I just recognize that this new, or sorry, I don't even call it new, I have a group or a multiset where I have one type of objects, another type of objects, and I just say, okay, what is the total? So this is kind of static grouping. This is kind of, so we have to distinguish joining versus grouping. In joining, you imagine another multiset coming and joining a previous multiset. Dynamic. This will help you solve problems. And grouping means that there is no joining. You already have a um, group or a collection of objects, and you somehow group it into two. You identify two types, like glass and plastic, or male and female, young and older. Yeah? Nobody is joining it, you are just grouping it. So this is static grouping, and this is dynamic joining. Both of them will translate to the arithmetic operation we call addition. So now I can try to undo what I have done. So from the joining interpretation, if I started with this new, these two new objects, join those three objects, now I have a new collection of 5 objects. And now what if I remove these two? So if I remove this, remove is the opposite of join. So then that will give me subtraction. So that will give me 5 minus 2. Yeah, the total 5 objects. You remove 2 objects, and then you are left with 3 objects. And if you want to write the quantity, you can do that as well. 5 cups minus 2 cups equals 3 cups. Remove something dynamic, where you remove something, delete something. But what if we interpreted that addition as a static grouping? Then you will not use the word remove. Then you can think of it as a whole part. You have a whole, yeah, a whole, and you say, okay, if I know the whole, that a collection has 5 objects, and you say that that collection has 2 parts, the whole has 2 parts, and let's say I give you 1 part, yeah? I give you 1 part, that if I have 2 objects in that whole of type plastic, and now I ask this question, what is the other type? This is called the whole part interpretation. What? Whole part interpretation. This is derived from the grouping of static interpretation. Removal was the opposite of joining. Whole part is the opposite of grouping. So I start from the whole with 5 objects. Yeah, whole, multiset representing the whole of something with 5 objects. I know 1 type, I'm asking the other type. This will give me the same answer. Yeah? So what I mean by subtraction now has 2 interpretations, either removal from a whole or whole part. You know 1 part and you are asked about the other part. One more thing is very important. These 2 interpretations of subtraction, this is called subtraction. Subtraction. So if I now summarize all of this, it's important for you to remember these names. I started with addition. Yeah, the plus symbol, and it had 2 interpretations. This addition arises when one group joins another group. You can also say combine. Yeah, total, whatever you use. And this is the dynamic interpretation. Yeah. Joining, like 3 birds joining 4 birds already sitting on a tree branch. And the other interpretation is the static interpretation. And that is not joining, that is just grouping of types. Yeah. You have a collection which has 2 types and you just want to know the total. From addition, we derive, so the opposite of addition will be subtraction with a minus sign. Yeah. And analogous to this, we will have 2 interpretations. If you are undoing, if mentally you are undoing this joining, you will use remove, delete, and so on. This will be the dynamic interpretation of subtraction. Similarly, if you are undoing the grouping, like you have a whole, so that will be called the whole part interpretation, and that is static interpretation. You are given the size of a whole as well as the size of a part of it, because it is of one type, and you are asked to find the size of the other part, given that you know the size of the whole. So that's it for today. In the next video, we will cover a third interpretation of subtraction, and that will necessitate to rework this addition, because the way we have defined addition and subtraction as the opposite process somehow is not enough to deal with that third interpretation of subtraction. That interpretation, in case you are curious, arises when you want to compare 2 things. That comparison is more complicated, so let's wait for the next video. Thank you. Bye.